So the first person that I'll introduce is Dr. Dan Javit. Dan Javit is professor of psychiatry and the director of experimental therapeutics at Columbia University. And he's also the director of schizophrenia research at the Nathan Klein Institute. So what is Dan best known for? He's probably best known for the work that he's, for the work that joins together the potent psychotomimetic PCP and the most commonly known glutamate receptor, the NMDA receptor, and its association with schizophrenia. This is now understood as being the basis of the current hypothesis of glutamate and psychosis. Dan and others have advanced these ideas, even now important in schizophrenia research and particularly important in schizophrenia therapeutics as well. By way of his contributions to science, I think Dan would like to be remembered in a broader context than that. First of all, he has critically contributed to the development of the glutamate model of schizophrenia, but he also has studied the mechanism of auditory and sensory deficits in schizophrenia. He's shown that early cortical processing deficits contribute to cognitive dysfunction in schizophrenia. And more recently, he really has contributed to biomarker development in schizophrenia therapeutics. With that, I'm going to introduce Dan Javit, who's won the Lieber Prize from NARSET.
Thank you very much. Okay, thank you, first of all, to BBRF for the award. Very much appreciated. And thanks to Carol for that wonderful introduction. My parents are theoretically listening online, some of those 1,500 people. So hopefully they heard it, and hopefully they believe it. And as an aside, my dad is a medical researcher, 97 years old, still publishing. So at least from his point of view, I'm only halfway through my research career. As Carol said, there are three main themes to my research. I lost 2 slides. Okay, there are three main themes to my clinical research. The first is something called the PCP model of schizophrenia. PCP is it's based on the ability of drugs like PCP and ketamine to induce symptoms that closely resemble those of schizophrenia by blocking something called the NMDA receptor. So it leads to the idea that there may be fundamental deficits in NMDA receptor function at the core of schizophrenia. Interestingly, one of the genes associated with schizophrenia, called the NR2A receptor, isn't expressed until maximum levels, until adolescence or early adulthood. So it could explain not only the features of schizophrenia, but also the characteristic onset, which is in late adolescence, early adulthood. So that's the basis of this story. What I'll be talking about mostly today is biomarkers, how we're using EEG and fMR to try to explain how basic deficits in NMDA receptor function give rise to the kinds of symptoms and signs that you see in schizophrenia. As a clinician, this is how we tend to describe schizophrenia. We tend to describe it as having symptoms, positive, negative, and cognitive, and also cognitive impairments in things like neurocognition and social cognition. And of these, it's really the experiential negative symptoms, things like apathy and avolition, and the social cognitive deficits, the difficulty in recognizing emotion based on tone of voice and facial expression, that really contribute the most to the outcome. But this is all about how patients interact with the world. If you ask patients as they're developing schizophrenia what they experience is that, okay, something happened to the slides. What they experience is that there are distortions in their auditory and visual pathways, so they actually experience the world differently, and they often have feelings of thought insertion, thought deletion, that are very bizarre. They know they're not true, but that's how they feel. So we started looking at those basic auditory deficits. This is 30 years ago, just using a simple paradigm where we okay, this is the first slide. Using a simple paradigm where we took two tones and matched them one after the other. So if you read the textbooks on schizophrenia, the textbooks will say that basic sensory processing is intact, that patients have no difficulty. It's one of the intact basic features of schizophrenia, especially there's a famous psychiatrist, Eugene Bleuler, who made the term schizophrenia, and he would say it's one of the intact basic functions. But when he spoke to patients with schizophrenia, that's not at all what they tell you. They tell you they have changes in their perception, and it's also not what we would expect based on NMDA models, because NMDA models at the time were saying that even though NMDA receptors aren't involved in the response to any single tone, they're very much involved in the comparison between tones. So here we developed a paradigm where we just took two tones, and the task was, are they the same or different? And if you do this in the general population, there's about a 3% difference. People need about a 3% difference. So that sounds something like this. Can you play that again? Didn't play right? Okay. Can you go back? Okay. Just play the one over here. Okay, play this one over here. Okay, so people need about a 3% difference, and if you test somebody with schizophrenia, they need about a 10% difference. So even though a very simple test, it shows a huge deficit in schizophrenia, and it goes along with what they'll tell you, which is what they have huge changes in their auditory perception as they develop the illness. We could then use our EEG approaches to help understand what was happening in the brain. So here, I'll see if this works. Here we play a series of, we put EEG electrodes on the head, we play a series of tones. It goes beep, 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 boop. And even if you don't hear, even if you're not paying attention to the tones as they're being played, the brain responds to them exactly like that. And you get responses from your auditory sensory cortex. So this is the first level in the brain where the tones are being produced, and you get this response that we can measure over the surface of the head. And you can see that in schizophrenia there are deficits, even in something as simple as that, reduced responses. We can show that if you give ketamine to healthy volunteers or NMDA antagonists to monkeys or rodents, we can reproduce this pattern. And in fact, this has become one of the best used biomarkers in schizophrenia. It may also be able to predict which individuals with early symptoms of schizophrenia will go on to develop the full-blown syndrome. So it's got a lot of uses at the basic science level and also at the clinical level, but I want to talk about here is how it affects the experience of people with schizophrenia, and when you, what tonality is used for, especially in Western languages, is conveying emotion. So the question is, what's the difference between these three sentences? Okay, you're going to have to play this.
It's 11 o'clock.
And the next one, let's see if this. Play this.
It's 11 o'clock.
And play this. Okay. Anyway, the utterances are basically the same words, but based on tone of voice, they're supposed to be conveying different emotion. And the only way you know that they're conveying different emotion, please don't play those yet. The only way you know that they're conveying different emotion is that, can you go back just 1 second? The only way you know they're conveying different emotion is by listening to the tone of voice. And what you should notice, first of all, nobody's very good at it, so even the controls are only about 60%, but patients are significantly impaired in it, and that impairment correlates, as we predicted, with the tone matching ability. Where it really hits home is if you look at angry over here, you say patients don't have a deficit in detecting anger, they're not different, why should that be? And you can come up with all sorts of theories, negative and positive emotions, or repressed anger at mothers. They always blame it on mothers. But if you look at how anger is perceived, can we go to the next? If you look at how anger is perceived, there are actually two ways of communicating anger. There's something called hot anger like this.
It's 8 o'clock.
And actually, that doesn't need any subtle processing of tone, and patients do just fine. But there's also what's called cold anger, which is this weird calm tone of voice.
It's 8 o'clock.
Patients just don't hear that. They actually perform a chant. So if you want to communicate anger to somebody with schizophrenia, you definitely should not use that weird tone of voice. It's also true with sarcasm. You can't communicate sarcasm because it depends on very subtle expressions. Another unfortunate thing is they also don't. They also tend to overrate emotions. When people are not intending to communicate emotion, they will interpret it as if the emotion they are, and they'll also tend to overrate the intensity of emotion. And that's because often we're trying to communicate calmness, but they don't hear the calmness, so they can't use that information to help themselves calm down. So the basic deficits in auditory processing cascade up the system and affect how they interact with other people.
It's 8 o'clock.
The same things are true in the visual system. Okay, same things are true in the visual system. You'll hear some of that from Dr. Martinez in the next talk. But I want to talk now is another aspect of NMDA dysfunction, which is the communication between brain regions. When one brain region does something, it's always communicating with the other brain regions through something called the corollary discharge to let them know what it's doing. And that also seems to be heavily dependent on NMDA receptor function, so something that should be breaking down in the brain. We started this about 10 years ago, just with a very simple paradigm called the eye soccer paradigm, where you see a ball in the middle of the screen, it's going to move, and you have to predict whether or not it'll hit that target. It can move for a short or a long period of time, and you can either stay at the center of the screen or you can track it while it's moving. And if it moves for a longer period of time, or if you track it, you do better. So this is the short, if you play that, and then the long, and play that again. And you can see if it moves for the long period of time and you track it, you have a better chance of predicting if it'll hit the target. And that's because the part of your brain that's moving your eyes is communicating to the part of your brain that's making that decision, and the brain can make use of that information. If you look at what happens in schizophrenia, the patients do relatively well at the short time period when they're not tracking. So they understand the task, they understand the instructions, they're trying to do it, but they just don't benefit either from the prolongation of the time or from tracking it versus not tracking it. So in both cases, they have significant deficits. These, as expected, correlate with the visual disturbances that they have, with the disturbances in visual learning, because it's a visual task, but they also correlate with that general psychopathology, and especially this disturbance of volition, the feeling that other people are controlling them. And it could be, in fact, because these cross-region connections, these corollary discharges are breaking down, and the brain really doesn't know what the other parts of the brain are doing, so it feels that somebody is managing it externally. We're starting to work on this with neuroimaging. And here we use an even simpler paradigm where people attend either to the auditory or visual. So they see visual stimuli, and they have to say where they are. They see auditory stimuli, and they have to say what number it is. And we can image the brain while they're doing one or the other. This is while they're attending to the visual stimuli. And what we're looking at here is not only the visual cortex over here, which we expect would have reduced activation. I should say these colors are the degree of activation of the brain while the person is doing the task. So we expect now these deficits in basic visual processing, but there are also deep structures in the brain. You can think of them as master switches in the brain, something called the pulvinar nucleus of the thalamus and the superior colliculus, whose job it is to keep the entire brain coordinated. So when you're attending to auditory or attending to visual, you have to turn off whole parts of the brain and turn on whole parts of the brain. And these are, in a sense, the master switches that make that happen. They're not activating in schizophrenia, and that may explain the feeling that people have with schizophrenia of feeling flooded, of not being able to process the environment, and also not even to be able to do simple tasks like this. So when you start thinking about these kind of abnormalities, the question is, how do these track up the system? And the way... can you go to the next slide? There should be a slide in between. There you go. One thing that you start looking at that you wouldn't look at normally is reading ability, because reading ability depends on auditory and visual processing. And if you, again, nobody ever studies reading ability in schizophrenia because the assumption is that if you learned how to read when you were a child, you know how to read later on. But if you see these kind of deficits, you think maybe they have reading deficits, and that turns out to be true. That as patients develop schizophrenia, they lose about 4 grades of reading ability. So if they started reading at the 12th grade level, they end up reading at the 4th. And that correlates with tone matching deficits because you need to sound words out when you're reading. But it also correlates, can you go to the next slide? With these corollary discharges. If you look at you're supposed to be able to have smooth eye movements when you read a page smoothly. If you look at the eye tracking of patients with schizophrenia, they get stuck in certain places. And specifically, when you move your eye movements, it takes coordination between a lot of brain regions to get to the word you want to read, and they just can't do that, and it slows their reading ability down. And just as a take-home lesson, very commonly, a young adult will go off to college, develop schizophrenia, they'll be put on medication, their symptoms will improve, but they'll try to go back to school and keep up where they were, and they can't, and we'll blame it on intention or motivation or something like that, but it could just be that they've lost the basic sensory abilities that let them read. And this is finally getting out to the clinic. Next slide. So this is our moving out to the clinic. This is in collaboration with the Lieber Clinic at Columbia with Alice Medaglia, Ali Saperstein. And here, there's been a lot of remediation work done in schizophrenia. Very little of it involves testing of sensory processing. So here we tested people for these basic auditory abilities before the illness, and then we also randomized them to a kind of remediation that either does have early auditory remediation or instead remediates things like attention and processing speed. And next slide. If people didn't have the auditory deficits, they did just fine without the auditory training, but if they did have the auditory deficits, they didn't improve unless there was auditory training. So if there was no auditory training, they didn't improve and probably were just frustrated by the entire experience. But if they did, they showed the same improvement as everybody else. And not only that, their negative symptoms improved, and not only after the training, but also at follow-up. So the hope is here, if we can address these basic auditory deficits, in fact, you can improve everything up the stream, and you'll hear more about that in the next talk about the visual system. Okay, next slide. So just take-home messages. First of all, schizophrenia is a whole brain disorder that affects basic sensory functions. These deficits in early sensory processing, which is what patients will tell you about if you ask them, contribute significantly to the higher order functions. You need psychoeducation to at least know the patients and families that this is what's happening so that they can work around it. Remediation efforts are needed to target these first before you can target higher level stuff. We were talking at the Scientific Council yesterday and we came up with the word pre-mediation. You actually want to try to prevent these deficits from happening instead of just treating them. Sensory and subcortical areas may be critical for neuromodulation. You'll hear about that next. And the only thing we haven't done yet is come up with a drug for schizophrenia based on the NMDA model, but I'm hoping to be able to do that in the next 30 years of my career. Next slide. And with that, I'll stop and just want to thank all my collaborators who made this work possible, all the people working in the lab so I can come up here and win the award and give the talk, and also the funders, including, of course, BBRF. And thank you very much.
Thank you very much, Dan, for the
questions, yes.
inaugural talk. We have questions now. And what we would like is questions from the audience. Single questions and a single question from a single person would be great. And if anybody wants to ask a question, would you stand up and I'll try to recognize you. While you're thinking about the question, I do have one, so I'll just take the moderator's prerogative. Dan, I want you to speak about, just say the name of any glutamatergic drug that's coming online for schizophrenia therapeutics.
So for glutamate.
For glutamate,
right,
yes,
so the ones
yes.
we've been testing, and there's a modulatory site on the NMDA receptor, something called Maybe I can go back to the talk. So, okay. Next slide. This is a slide that I couldn't find at the beginning, but this is a cartoon of the NMDA receptor. And so the main neurotransmitter is glutamate, but there's also a modulatory site here for glycine and D-serine that turns on or off the receptor. And we've done work with it, and there's very interesting work done with other people. These are natural amino acids, so they're a bit hard to use. And not everybody who has NMDA receptor dysfunction has it because they have something wrong with glycine D-serine, and that's one of our challenges, that there are many different ways these can break down, but there's a very interesting family, and actually they're the sister and niece of Glenn Close, and it's on her website, so I'm not saying anything. And they have a mutation that's never been found in anybody else with schizophrenia, but it's a triplication of the gene that breaks down glycine in the brain. So they have very low glycine levels, and they were ill for a long time until they went to McLean Hospital. Anybody here from McLean? And they had their genetic sequencing done, and they found the mutation, and they were given glycine, and their symptoms totally resolved. Unfortunately, they've been ill for a long time. Their lives didn't go back to normal. But it gives hope that if we can identify a subgroup of people where it's really this glycine D-serine metabolism that's causing the deficit, then we'll be able to treat those, and then there are drugs like glycine transport inhibitors that might be better. But right now it's hard to figure out exactly why everybody has deficits. There are some genes, some genetic abnormalities where actually this NR2A receptor has a mutation in it where it just doesn't get expressed.
And there might be a family of glutamatergic genes.
And there might be a family, right, okay.
That eventually get discovered.
Exactly. There's more to do. I won't give another lecture. And
well, you can give another lecture. I wanted people to know that there are practical treatments coming from what you all heard now that have to do with the glutamate receptor, which is a very complicated receptor. Questions? Yes. Excuse me, I don't know your name.
Hi, everyone. I'm Miriam. Brainify AI. Oh, thank you. Miriam, Brainify AI, doing research on the biomarkers in the EEG. And so my question is very basic. Mm-hmm. Do you do clusterization among sexes when you study your patients on biomarkers? And do you see any sex differences in the biomarkers? Because this is something which we come in very often along, because we see significant sex differences in the brain activity when it comes to schizophrenia and other mental disorders.
Right, so I think the question was, do we see sex differences in our biomarkers? And we always, of course, look at it. It's something we look at both in our human studies and our animal studies, so it's built into all our research. And there is, as you say, schizophrenia does tend to affect men more than women, and also men to be affected earlier. But in terms of the biomarkers, they tend to be very similar across men and women, and they all line up on the same correlation between severity and degree of biomarker disturbance across the different, across men and women.
Men are bigger and stronger than women, so there's a difference between a psychotic man and a psychotic woman, but that may not necessarily be in their genes. Well, it is in their genes.
Right, they're more similar from the neck up than from the neck down.
Yeah, right. One more short question, please. There's a microphone coming.
I was just wondering what you thought of the new drug, like Cobenfy.
Cobenfy.
Will that be less sedating, and do you have hope for that being going with future treatments?
Right. So the question is about Cobenfy, and it's one of the most exciting developments in schizophrenia research. In the last couple of decades, it's a new medication for schizophrenia. It works on the same kind of pathways that dopamine D2 receptor antagonists, antipsychotics work, but doesn't bind to the dopamine. So it's got less sedation, it's got fewer dopamine side effects, maybe other side effects, but definitely it's an exciting new drug and may be very helpful for some people that haven't been helped by antipsychotics.
With that, I'll thank Dan Javit for presenting and for winning the prize.
Thank you.